Okay, we continue from last week. Last week we stopped at finding the solution concentration by mass percentage. All right. So last week, what we do is in a solution, to find the solution, I write something on the whiteboard. You need solute and solvent. So you need something to dissolve in a solution. Then there are a few types of solution: unsaturated, saturated, super saturated. Okay, this was covered by previous lecture. All right. So from here, last lecture, we cover all the concept. Now we go into calculation. So we deal with what is the concentration, right? Percentage of concentration. So first equation that we covered last week will be the mass percentage is a mass of solute, M solute, plus mass of solute plus mass of solvent multiply 100%. Okay. So this is the equation that we covered. So sometimes we can write in how many gram per 100 gram solution also. Yeah? So sometimes, or another presentation, we can write in how many 100 gram of solution. What is the X gram of your solute? Okay? We focus on the solute. Solute is a minority component. Let's say I just put the salt, the one that you familiar, the salt, NaCl. And then the solution, the one that you familiar is the water, H2O, with the majority component of the things, right? Yeah. Okay. Then, for example, if we have 3.5% a solution containing 3.5% sodium chloride, so how you convert into gram? Yeah. So you have 35%. So let's say you are given 3.5%. It means you need to take 3.5 divided by 100. Okay. So this is how you do the conversion. How you call conversion? So if you want to do convert gram solution into gram of solute, you use this conversion. If you want to convert gram of NaCl into solution, you reverse the fraction. Okay. But anyway, what is important here is the top solution. You need to write mass percentage equal to how many gram of solute divided by 100 gram of solution, or the one that with 100%, this one. These two definition. These two definition is important. Once you write this one, you're able to substitute the missing number. Okay. So we're going through this one, and okay, so this one, consider a water sample from bottom lake of something. It gives you a scenario. We give you 8.5% carbon dioxide by mass. So this one is percentage by mass. So when you see this kind of question, is fall under chapter 4, it asks you about concentration. So when it asks you concentration, you write percentage of mass equal to how many mass of solute divided by the total solution mass, multiply 100%, or you can write in X gram of solute divided by 100 gram of solution. Then you back to the question, it gives you 8.5% carbon dioxide CO2. Determine how much CO2 in gram is contained in 2.8 liter of water, and it give you the density. When you give you a density, normally you need to convert back into how many gram? Okay, so the mass, if you're given density, mass equal to rho multiplied by the volume. Okay, so need to convert, need to write the general equation. Mass equal to density multiplied by volume. Then you find 2.8 liter of water got how many gram? Right? You convert 2.8 liter of water into gram. Okay. So this is the mind map where liter in this one, this question a bit tricky and is about the standard of your test or final exam. You see the unit actually a bit tricky, right? So it gives you the density is 1.03 gram over milliliter. And in the question, it gives you in liter, 2.86 liter. So you need to convert this one, milliliter, into liter. This is some of the tricky part that I usually use in the question coming up in your test. So watch out for next week test. Usually the question I will play around with the unit. So be careful when you read the question, right? So you know that milligram, you convert into index. Milli is 10 power negative 3 liter. You just need to write like this. Okay, so you convert rho equal 1.03 gram over ml. You put in the conversion 1.03 gram. I write something on the whiteboard. 10 power negative 3 liter. You rearrange the equation. If you already pass your algebra or mathematics, I assume you already know. This one you can write 1.3 10 power 3 gram over liter. You can write something like this. Okay. Now, when you come to chemistry 2, I assume you already have and passed all the maths. So this one should be no issue for you. Right. So first is conversion of all the unit into the one that you can use. Okay, now the question asks, the information give you 8.5% of carbon dioxide by mass. So you write this statement out and then write the general equation. What is percentage of mass means? You write the general equation, then you convert into the useful information you have. All right. So what actually we need is so relationship. This one is the behind thinking. So to solve this one, you need to convert the useful information. Like for example, the density is in milliliter. You need to convert into liter because the question gives you in liter, 28.6 liter. So and then you convert lah. So 8.5 gram over 100 gram solution. This is the definition of percentage, 8.5% carbon dioxide by mass. You can write in the form of 8.5 gram divided by 100 gram. Okay, this one by definition of the concentration. Yeah, this one given by this information. Okay, by these slides. Okay, so for new joiners, for chemistry 2, when you answer question, you need to give me the equation. general equation, then only you do substitution. You substitute the value, then you give me the final answer. Right? You find the x equal to what with the unit. Okay. So for the test one or final exam, give me at least 2 decimal place. At least 2 decimal place with the correct unit. So from here, we continue this example. You convert information 8.5% carbon dioxide by mass. You convert into 8.5 gram divided by 100 gram of solution. So and then you're given the density 1.3 gram over ml. So ml you need to convert into liter, right? Okay, to liter. So milli is 10 power negative 3. This one I did write on the whiteboard. So you need to write 8.6 solution equal to how many liter? Right? So 8.6 okay, this one is a little bit reverse back. You can convert the 1.3 gram over liter, or on my slide here, the answer is given in ml. Either way also can, as long as you able to find the final answer. Okay. So once you convert, you're able to find in 28.6 liter of water, you're able to find it is 29.458 10 power 3 gram. So it's always good to have 2 or at least or 3 decimal place in your answer. It is for accuracy. Because after your foundation, you're going into degree. So it's good to have all this scientific accuracy there. So this is PowerPoint, my PowerPoint slides. But what is expected in your test? How you write? This one I already done in the previous class. So you need to find you need to convert 2.86 liter equivalent to X gram of water. H2O equal to X gram of H2O. So to find X gram of H2O or water equal 28.6 liter multiplied by the rho, because this is the volume, right? So you convert into multiply by 1.03 milli, I change into liter. This is another kind of form of answer that you can use. Power 3 gram over liter. But the final answer is still the same. Final answer is still the same. You need to show me how you get the correct unit. You need to cancel the liter in your answer. If you press calculator, you still get 29.458 10 power 3 gram of H2O. Okay, so this is the expected answer in your test if this one come out Okay, the one that you see on my PowerPoint slide is just the scratch of the solution, right? So then you convert into CO2. So it gives you in the water, the concentration is 8.5. The concentration is 8.5% of CO2. It means you have 85 gram over 100 gram. You have 88.5 gram of CO2 in 100 gram of your solution. Yeah, in your solution. This solution. So you define how many grams you have, right? So you take this one, 29.485 multiplied by 10 power 3 gram multiplied by the ratio, the concentration, because you have 8.5% by mass. So you take 8.5 divided by 100. The final answer is 2.5 10 power 3 gram CO2. Okay, it's still back to these two formula. Okay, still back to two formula. It's just that this example, it straight away give you the solution total mass. Yeah. So when you read the question in test, just read carefully what are the terms that we use in the question. Okay, we still apply the general equation of percentage of mass equal to mass of solute divided by total mass of the solution, water, multiply 100%, or in the simplified form, you can take the solute divided by 100 gram of the solution. There are two forms of equation here. Yeah. All right. So this one, okay. Let's try another one. If you're given a soft drink contain 11.5% of the sucrose, by mass, so you know that if you read the question, it gives you percentage of something by mass. This is a concentration question. You need to use back chapter 4, concentration section equation. So this is the first one. What volume of the soft drink solution in milliliters? So this one question force you to do unit conversion in milliliters, contain 85.2 gram of sucrose, and then it gives you the density in milligram. Okay, so maybe you spend some time think about it, how you do it. All right. The question asks you about volume. Okay. So I left the two general equations on the whiteboard there. I will write something on the whiteboard on the right hand side. 11.5% of sucrose. So if you, the first step is you write these two equations. Then you follow by the question information. You write 11.5% sucrose by mass equal 11.5 gram of sucrose. You write lah, by sucrose by 100 gram of solution. Because this question, it gives you solution. The question do not ask you about mass. It do not give you the mass of solute. Then you don't need to use the top equation here. If the question you see, it gives you the mass of solute, then you use the first general equation here. If you see the question give you the solution, total mass, then you use the second equation, which is the divide by 100 gram. Then it asks you the volume of soft drink solution in milligram that contain 85 gram, 85.2 gram of sucrose. Okay. So you don't know the V here. You don't know the volume here. X. I just put X volume here. Okay. You are given the rho, density rho, 1.04 gram over ml. So to find this volume, you need to convert into mass because the definition of concentration is in mass. So you need to convert into volume. So 100 gram got how many volume ml, right? So you can convert lah, do the conversion, convert this one into volume, then you're able to find. Yeah. Okay. So you know that 11.5 gram of sucrose you convert into gram unit, which is divided by 100 gram of solution. Density is milligram, milliliter, sorry, 1.04 divided by ml. So this is given. So what you do is you take 85.2 gram, you multiply by the 11.5 gram, divide by 11.5, multiply 100 gram, because you want to convert into solution. Okay, maybe I do, maybe the answer on the slide a bit too fast for you. I break it down for you. So you want to find the volume. Okay, so how do I put it in the language that so 85.2 gram. You want to know this one got how, just put it y gram of solution equal to 1.5 gram of sucrose over 100 gram. I mean the concentration, the concentration here. We talk about concentration. Concentration here, it must be the same, right? Right. These two containers, the solution must be the same, right? So this one, 11.5 divided by 100 is given by the question. So this one is the concentration, percentage of mass. Now you're given this question. You want to find how many gram, right? So you want to find the gram, you just cross the question, right? So to find the gram, y equal, okay, y multiply 1.5 gram equal to 100 gram multiply 85.2 gram. Then you rearrange 100, 85.2 gram divided by 1.5 gram. Okay, now you can find what is the bottom y here. All right, so you can find the y gram by pressing your calculator. Yeah, your calculator should tell you 340.870. Okay. So basically the question asks you to balance the equation or just to equalize the equation. All right. And draw something on the whiteboard just in case you're unable to imagine what actually the question gives you. The question gives you the solution percentage by mass, the concentration. It gives you the concentration of 11.5%. Okay, by mass, sucrose by mass. So this one actually it means 11.5 divided gram over 100 gram of solution. Then the question gives you want to have the same concentration. Want to have the same concentration. Now what is changed? The volume change. It gives you inside this new solution have the same solution. Inside the solution got 85.2 grams of sucrose. What is the volume of this new solution? The concentration still same. So you want to find, before you find the volume, you want to find how many grams of this solution. How many grams of this solution? You want to find 85.2, this Y solution, gram of solution. It must be the same concentration of 11.5 divided by 100. These two containers must have the same concentration. So that's why I write something on the whiteboard here. From the equation that I write on the whiteboard, you'll find Y equal to 740.870 gram. But the question asks you volume. You are given density. Density is what? Density is mass divided by volume. Right? So to find the volume, you are given the volume 1.04 gram per milliliter. Okay. Now you have okay. You have the mass, you have the density, you don't know the volume. Right? So you move the unknown to the left-hand side. Right? So volume equal mass divided by density. You substitute the value. The mass will be 740.870 gram. Density is 1.04 gram over ml. You can cancel the unit gram. You only left out ml. You divide, so you move to the top. At the end, you get the unit in the answer in ml. This is just a mathematical conversion. Right? The final answer for this question is 712.375 ml solution. This is a tutorial question. Sometimes the question in the test or final exam, it might ask you in liter, but the density give you in ml. These are the trick lah. Okay, just pay a bit attention to the unit. Any question so far? Able to follow? Yeah. Okay, so let me see. So this is your homework on to test whether you understand or not. This one, you are containing 1.5 sucrose. You are given percentage by mass. So convert 11.5% sucrose by mass in the ratio of 100 gram of solution. All right. Then ask you what volume is the soft drink solution in ml contain 85.2 and give you this one. He asks you how much sucrose in gram is contained in 355 gram of soft drinks. So once you find the answer just now he asks you how much sucrose in gram is contained in 355 gram of soft drinks. This one actually is just reverse the equation. Okay, if this question come out, how to do? He asks you, once you solve the top part, now he asks you in the container now, concentration already given. The concentration is 11.5% by mass. So this one, in other meaning, is 11.5 gram over 100 gram of solution. So this one, 355, is actually is solution. Now, you want to convert 11.5 gram per 100 gram into a new conversion, which is now you are given the 355 ml here. So what you do, you convert 355 ml into gram, because the density is given 1.04 gram per ml. Convert 355 multiply 1.04, you get gram of the solution. You cross the equation. Just now, you cross the equation, you're able to find the Y value. Okay. Okay, now if you don't know, you can just illustrate your answer with the diagram, like what I draw on the whiteboard. You can draw two containers. One container with the known concentration. Then another one is from the question. It gives you a new parameter. You will find what is the missing parameter. It must, the two container, the new container will have the same concentration as the given in the question. Then you cross the missing numbers. Yeah, so this one is actually the mathematic part. Still back to the two equation. So this is just a revision what we have done last week or last lecture. We still back to these two equation. When you answer, you see the question asks you percentage of something by mass. First step in your answer, we expect you write the general equation. You write the top one or the second one, depend on the question. But it's safe to write the two lah. So the first step, you write mass percentage equal to mass solute divided by mass solute plus mass solvent multiply 100%, or mass percent equal to gram of solute divided by 100 gram of solution. You can put the x gram of solute divided by 100 gram of solution. Then you back to the question, you substitute the missing value. Yeah. So if you see density, this one is your physics class. It's back to your physics class already. It's not a chemistry things, it's a physics class things. Right? Okay, so we have done with the percentage of concentration. Now we go into a chemistry dimension, which is we will use mole now. How we calculate the mole? Mole that you learn in your chemistry 1. Now we focus on the molality, mole. Okay, recall back 1 mole have 6.0 something 10 power 23 atoms molecule. That is the definition of 1 mole. And also back to your chapter 1, you have a periodic table. In a periodic table, you have the atomic mass number in your periodic table. Inside there, you have a small number there. For example, carbon 12, you have 12.0 something gram per mole. This one is in your chapter 1 content. So newcomers, you can download information from the island. Refer to the periodic table. You're able to find one element from the periodic table. There's a number there. So for example, carbon you will see is 12 point something gram per mole. Today we want to find the concentration in mole. So concentration, second way of defining the concentration is in molarity, or we'll represent as a capital M. Defined as the number of mole of solute per liter of solution. Okay. And in chemistry, we'll use bracket to represent mole. It will be in number of mole over liter. Number of mole of solute. Solute means the minority component. If you take water and salt, salt is the solute. You take how many solute per liter of solution. If you see solution means you can use a second definition. How many solute over gram? 100 gram. Okay. So this, if the question asks you molality or mole, you need to write this general equation. You need to write molality bracket capital M equal moles solute divided by liter solution. You need to write this one in your test answer or final exam answer. You need to tell me what actually equation that you use to solve the question. Yeah, so I think this one you should already be familiar every time I've mentioned in the class. Start your answer with general equation, then you start substituting number. Then you tell me the third, okay, the question in chemistry 2 will be section A. Normally the question will be asked you about definition. Normally your answer will be in general equation. Second part of the question, you need to substitute value, do analysis, use simple mathematics, plus, minus, division, multiplication, right? Just rearrange the numbers. Then you get the answer. Part 3 of the question, you need to tell me what does that number mean to you. Okay? So that is the sequence of how you answer chemistry 2 question. Okay, this is just a highlight. When I highlight in my slide, you see red color one is mostly will be the mistake done by the student in exam. Be careful, molality is solution. The bottom one, denominator, is solution and not solvent. You need to differentiate what is solvent, what is solution. So again, you want to have a solution, you need two things, which is solute and solvent. Solute is something minority. For example, I take NaCl, salt, you plus water. Don't use the wrong component when you calculate molality. Molality, we focus on the minority component, which is solute over solution. Careful, this one. This will be the careless mistakes in the exam. Okay, so this will be another illustration how we get 1 molar of NaCl. So 1 mole of NaCl. How you know you can get 1 mole of NaCl? You use your periodic table from chapter 1. Na, how many? Do you bring your chapter 1 question, or you can just Google lah? What is, or you can just Google periodic table. You can download, or you can go to Island, download the chapter 1 soft copy of the tutorial. NaCl, how many gram? If you use a periodic table, Na how many? Na how many? Na? How many? 22 point something lah. Na, Cl? 35. So will be, if you add these two together, you'll get 57 something lah. Okay, but okay, so 57 something gram NaCl will equal to 1 mole. So that's why in these slides, it takes 58.44 gram. This one is a very accurate number referring to the periodic table. The total atomic number, gram, Na plus Cl, you get 58.44. This is how you get 1 mole of NaCl, because it's a combination of molecule. Then you'd use this 1 liter container in the chemistry lab. There is a marker here. There's a marker on the container. In the lab later, you need to be careful on the marking. So there's a marking there to indicate there's 1 liter marking. You put in the NaCl, the salt, 58.44 gram. Then you put in distilled water. Distilled water up to 1 liter, you shake it, you'll get 1 mole solution. Okay. Now from this slides, you already know 1 mole of NaCl concentration, you will have 58.44 gram over 1 liter. Okay, 58.44 NaCl over 1 liter is called concentration. Yeah, so this is how you prepare 1 molar of NaCl solution. So from here, your salt is solute. Water, distilled water is solvent. So solute plus solvent, you get solution. Yeah. So during the lab later, don't tell me, sir, I don't know how to prepare how many mole of solution. Already know. So this one is chapter 4. Okay, this one you read. This one you read. I already explained. Okay, this one. If you understand the definition of molar just now, molarity, 1 mole of something equal to something of your solute per 1 liter. Calculate molarity of sucrose solution made with 1.8 mole of sucrose, dilute in total volume of 5 liter of solution. Okay. So just monitor the standard procedure in chemistry 2. I do one standard answer on the whiteboard before I show you the answer. What you do, you see molarity. So it is fall under chapter 4. Recall chapter 4 molarity general equation. Molarity, you write molarity equal gram of solute over 1 liter of solution. Then you calculate sucrose. It gives you the equation C12 H22O11. So this one molecule got how many gram per mole? Right? So means if you calculate the atomic weight, 12 carbon plus 22 hydrogen plus 11 oxygen atom, you add all these one, become total gram over total gram, it will become 1 mole. 1 mole have so many gram. Okay, so I just put this one as your X, capital X. Once you find the X, right? Once you find the X, it will tell you. Then it give you, if you don't know, you just draw a container. You have 1.58 mole of sucrose, total volume 5 liter. So you know that molarity equal how many gram of solute divided by 1 liter of solution. Now you have mole of solute. This is a solute. So these two must same. You imagine this one as container. You must have similar with the new container. So 1.8 mole equal to how many gram? You don't know. Because you need to put the number here. Right? This one mole, this mole of sucrose, equal to how many gram? You need to convert. So how you find this one into gram? 1.58 mole multiplied by the capital X gram per mole, you get Y gram of sucrose. Make sense? You cancel more. So you get capital Y gram of solute. This one, 5 liter, right? You just continue to use the 5 liter. Press calculator, you get the Z value in gram over liter. Or in mole. Okay. So I'll show you the answer on the slides. Molality equal to mole of solute divided by liter of solution. So 1.5 mole divided by 5 liter is 0.32 mole. Okay, but at the end you still get 3.52 lah. 0.32 mole. Okay, this one is a bit direct, but of course in test you won't be like the same as tutorial. In the test, you won't direct. You won't get 1.5 mole. You'll be given how many gram of sucrose. You need to convert how many gram of sucrose into 1.5 mole, and then you divide by 5 liter. Okay, so if the question asks you molality, the answer will be in unit of capital M. If the question asks you percentage of mass, you need to give me percentage mass. You need to write by mass or something. Be careful on the unit. There are two types of unit. One is percentage of weight, percentage by mass. One is M, molar. Okay. Mole per liter. If the question asks you mobility, you write it mole per liter. Okay. Next one. Next one is another one. Just now, the example give you straight away in mole. This one more likely will be the format of your test or final exam. You will see the solute will be in gram. You need to convert in mole divided by the liter. You need to write the first equation, mobility, capital M equal mole solute divided by liter solution. Then you look at the question, what info is given. You are given 15.5 gram NaCl into a breaker, adding water to make 1.5 liter of NaCl solution. You need to convert 15.5 gram into mole, then divide by the liter. Okay, 15.5 gram into how many mole? You use the atomic number. You know the NaCl atomic number is 55.44. For chemistry 2, use minimum 2 decimal place. Okay, use the 2 decimal place in your calculation and also answer. You take 15.5 divided by 58.44. Okay. Maybe the slide is not here. I write something on the whiteboard. It's the same presentation. The slide is show you a neat way of writing equation, but you can write your answer like the one I write on the whiteboard. Okay, so 1 mole of NaCl equal to 58.44 gram. Then you substitute lah. You write the general equation, molality equal to mole divided by mole of solute divided by liter of solution. This one you need to write in the all kind of question. You need to write the general equation to justify, right? To answer whether you understand the question or not. Start with the general equation, you need to write, then substitute the value. Okay, 0.177 mole. Don't assume the standard of test and final exam will be the same as tutorial question. It won't be the same. It will be a combination, maybe 3 tutorial question equal to 1 test question. How we test you, I'll play around with the unit lah, usually. ml, I will ask you, I give you density in ml, gram over ml, I ask you liter, something like that. Okay. Okay. Now, how do I change this question into a test question or final exam question? I will change the 1.5 liter into volume, maybe. I give you how many, maybe I give you how many grams of water. I give you density. You need to find the liter. Okay. You try to understand how your lecturer asks you question in the test or how you're being evaluated. Okay. So basically, we want to know, do you know the general equation to use or not? Which general equation you use? You write the general equation, then you do conversion. You do know how to do conversion of the unit. Then you substitute. Okay. Final answer, give me the correct unit. Yeah? If the question asks you molality, you need to answer in M. Okay. Another one. I think this one is this one. Okay, this one is just a conversion factor, how you reverse here and there. Okay. For example, 0.5 mole of NaCl contain 0.5 mole of NaCl per liter. So if the question asks you how many mole, you just convert accordingly. This is just a mathematics conversion, right? Now, for example, determine how many grams of sucrose again are contained in 1.72 liter of 0.75 mole of sucrose solution. This one actually reverse the equation. So first, again, you write mole. It gives you the mole in mole. So you write molality M equal to X mole of solute divided by 1 liter of solution. Now you are given a new container, 1.72 liter. Inside there got 0.7885 mole. Okay. So you are given the mole of this one. And you're given the total volume of the container of the solution. Okay. You know that 1 mole, you need to calculate 1 mole of sucrose equal to 342 0.34 gram. This one you calculate from the periodic table. Yeah. Okay. So in chapter 1 and chapter 2, we cover how to use periodic table already. Periodic table will be your best friend in chemistry too. Basically, all kind of question you need to use periodic table. Okay. Then you solve it. 1.72 liter, you convert into how many mole of solution? Yeah. So this one, you are given 0.758 mole. With this, you will have 0.758 mole of sucrose over 1 liter. Now you have 1.72 liter. It asks you got how many sucrose. So basically, you're finding the X lah. Okay. Zero 0.58 mole sucrose over 1 liter. It asks you the X, which is the mole of gram of sucrose. If you have 1.72 liter, from this mole, you convert into gram. Okay. So 1.72 liter got 1.304 mole of sucrose, then multiply by the atomic number, atomic weight, you will get 44.6 gram. This is how you prepare solution. If in the experiment it asks you to prepare 0.758 mole of sucrose, you should able to do lah. You know the volume is 1.72. You need to know how to calculate. You need to add 446 gram of sucrose to get 0.758 mole of solution. Yeah. Basically, we're still doing the same equation. Molality equal to X mole of solute divided by 1 liter of solution. You find how many moles inside the solution, then you find how many gram of that. In the test, you don't need to show me the solution map. You don't need to, you need to show me the relationship, means the general equation. You need to show me general equation. What is molality? Then you do calculation. Okay. How many liters of 0.114 mole NaCl solution contain 1.24 mole of NaCl? Try to think whether you know how to do or not. This one is just a rearrange of numbers. First, write the molality equation because it gives you the mole. And ask you liter. So you have 0.114 mole. You don't know the liter, or put X liter here. You have 1.24 mole of NaCl. Basically, only one unknown is missing in the equation. Rearrange. Mole per liter. Huh? So mole per liter. Mole per liter. Okay, just rearrange 1.24 divided by 0.114. Okay, so you just take 1.04 divided by 0.114. This is just a direct application of equation. Okay, nothing complex here. Okay. You need break. Okay, we have a short break. Now it's 12:18. We continue 12:30. Okay, 10 minutes breaks.